find magnetic field at O due to this infinite wire, semicircle and infinite wire. So since current is flowing, this portion will produce magnetic field at O, this will also produce at O, and this will also produce at O. We have to find out what is the combined magnetic field, that is vector sum of all the magnetic field at O and its direction. First let us see portion 1. For portion 1, see, this is the general form of Biot-Savart law, which is produced by a current element, and this is the formula which we have derived from this formula, that is, this is the magnetic field for due to a long wire, straight wire, long straight wire. So this is portion 1. For portion 1, we will take like this. This is goes up to infinite. This is portion 1, and this is O, and this distance is R. That is A. What is A? A, here A is equal to perpendicular distance of O with wire, straight wire. So it means we can say A is equal to R here. We have to find out this portion. Now from this point O, we join one end and we join another end which is at infinity. It means with the reference line, this line joining this point and this point. See, if it is like this and this is the perpendicular distance A, this is, we join one end, we join another end, and this is phi 1 and this is phi 2. Here the perpendicular distance also in the same line, this is the perpendicular distance, A also in the same line, and the line joining O with one end, and we can say end A, with the end A also same, therefore theta, that is phi 1 is equal to 0. Phi 1 is equal to 0. Then what about phi 2? Since it is an infinite wire, phi 2 initially the line joining the point at which we are interested to find out magnetic field and joining other end, that is, this is going infinite. It means if it is here, it will be like this. If it is further increasing, it will keep on increasing up at infinite. The angle between this reference line, that is perpendicular length, and this line joining this portion up to that other end will be 90, because from here it will go like this. At infinity, the angle will become 90 degrees. So we will use this formula. What is the magnetic field portion for portion 1? B is equal to mu naught by 4 pi. This is standard, always it will come into I. I will also come divided by perpendicular distance A. A is equal to, here A is equal to R into sine of phi 1 is 0 degree plus sine of phi 2 is equal to 90 degree. This is equal to 0 and this is equal to 1. Therefore, B is equal to mu naught by 4 pi R into I. So this is due to this portion. Which portion? This is portion 1. We can call it B1. And in vector form, we have to see in vector form how we will see. We will make it, this is the magnitude portion. In vector form, since the current is flowing this way, thumb will come here, right hand, thumb will come. Here it will go into, and here it will go into, and this portion it will come outside, it will come outward, that is outward here. So the magnetic field will be outward. Now second portion. For the second portion, it is a semicircular ring. Semicircular ring means what? We can already, we have derived in the previous question also. We have, what is this? we will use this formula, that is B is equal to integral of dB is equal to mu naught by 4 pi, this formula, into what about theta? Theta, for this theta, see this is a dl vector, this is r vector, therefore theta is equal to 90 degree, because this is a dl vector, this is r vector, we can take anywhere here, even if you take here, this will make 90 degree. So it's equal to 90 degree mu naught I by integral of, because dB, if you are integrating, we have to integrate this portion, mu naught by 4 pi into I divided by r square into dl into sine 90 degree. So sine 90 degree is sine 90 as it is equal to 1. So this we can write B, that is B for the second portion is equal to mu naught by 4 pi into I divided by r square into integral of dl, since this is equal to 1. What is integral? For semicircular. For circular portion, length is 2 pi r, because it is the radius r. For full circle, its length is equal to its circumference, which is equal to 2 pi r. For semicircle, half of it is equal to pi r. So integral dl is equal to, this is equal to total length of the semicircular wire. So we can write B2 is equal to mu naught by 4 pi into I divided by r square into pi into r. Or we can cancel this and this and this also we can cancel. Therefore B2, what is B2? B2 is equal to mu naught I divided by pi cancelled into 4r. Or we can find out this way also. B2 is equal to mu naught by 2r into angle subtended divided by 2 pi. Angle subtended is pi. This is equal to pi cancel, that is mu naught into 4r. Straight result we will get mu naught into 2r into pi divided by 2 pi. This we get the same result as this one. So this is shortcut way, mu naught I, I will also come here, mu naught I. So B2 we have find out. Now we have to find out the direction of B2. Again we use our good old rule, that is right hand thumb rule. See, current is coming this way, see current in this, let us take this portion, DL portion. So current is coming this way. The current is coming this way, right hand thumb in the direction, and it means here in this portion it will come out, and this portion it will come out, this portion it will go inside. It means come out means outward, here is inward. We are interested to find out at O. This will produce a outward magnetic field, and this portion also produce outward magnetic field, so we can write it, this is also outward. Now third portion, again we will use the same one. This is our O, this is the line, this is DL, and this is a conductor. This is DL conductor, this is R, this is O, this portion up to here, this one R, and it goes up to infinity. It means the A is equal to perpendicular distance, which is nothing but the radius. This is the reference line. So with respect to this point, we join a line from here to one end, from here to another end. It goes up to infinity, because at infinity we cannot mention it here. It means what is the angle? This is the perpendicular distance A or R in this direction, and what is it? There is one line and another line joining one end with respect to O, and theta is equal to 0 degree. Angle between the perpendicular distance and the line joining this point to one end, both are same, it means theta is equal to 0, or we can say phi 1 is equal to 0, and obviously phi 2 is equal to pi by 2, that is 90 degree. Why? From O, this is the line joining perpendicular distance, this goes up to infinity. It means this is the line, it joins at infinity. See, if it is here, this is phi 2. If it is here, this end is here, this is phi 2. If it is here, this is phi 2. But if it is goes to infinity, it will go, because the length, the line joining this and this is meeting at infinity. It will go like this. Because this will also keep on increasing, this line elevation also. From here, it will go like this. So, phi 2 is equal to 90 degree. Right. Therefore, phi 1 is equal to 0, phi 2 is equal to 90 degree. In that case, we can write B is equal to mu naught by 4 pi into I divided by A. A is equal to R, because this is the line joining O with respect to one end perpendicular distance A is equal to R into sin phi 1 plus sin phi 2. Sin 90 is equal to 1, sin 0 is equal to 0. Therefore, magnitude of B due to this infinite wire at O is equal to mu naught by 4 pi into I divided by R. Mu naught by 4 pi into I divided by R. What about the direction? Since the current is flowing, right hand thumb rule, current is flowing this way, we hold it like this and curl it. It means outside it is outward, because this point is inside. This is outside, the magnetic field will be inward. We are interested only this portion. Everywhere it will be inside. So at O, the magnetic field produced by this one is outward. So all are outward. And B1 and B2 also same, like B2 is equal to B3 also. Portion B3. This third portion also bring same. This stands for outward. And this stands for inward. This we must be aware of the sign convention. So it means now we have got our magnetic field produced by all the three segments. One is semicircular and two are infinite wires. And we are interested to find out magnetic field at the center of this semicircle. So since magnetic field is a vector quantity, therefore B net due to all this one is equal to B1 plus B2 plus B3. B1 plus B2 plus B3, or B net as a vector B1. What is B1? B1 is equal to mu naught I. B1 is equal to mu naught I by 4 pi R. All this is outward, and B2 also same, plus B2. So we can write this is outward plus B2 is equal to mu naught I by 4R outward plus mu naught I by 4R outward. It means all are outward. We can say take mu naught I by 4R, we can take it commonly out, is equal to 4 by R. This is equal to 1 by pi plus 1 plus 1 by pi is equal to, and these are all are outward. It means net field will be outward at this point. At this point the net field will be outward. Is equal to mu naught by 4R into 1 pi plus 1 pi, 2 by pi plus 1, and the magnetic field direction is outward. This is the net magnetic field produced at O. Due to this, all the three elements of the elements in which current is flowing.